Good morning, students. Today we are going to learn the topic strength of acids and bases. We have already finished what is acid, what is base, what is salt. We have also discussed what is common among all the acids. It is H plus ion. What is common among all the bases? It have a replaceable or OH minus ion. Okay. The salt, which is formed by combination of acid and base or neutralization of acid and base. Then how to identify this substance? We have learned it is the indicator which gives whether the substance is acidic or basic. So these indicators gives acidic and basic character. Now, how much stronger is that acid? Means acid contain H plus ion. But it is possible that some of the acid may give more number of H plus ion, or some of the acid can easily give the H plus ion when it is dissolved in water. But some of the acid may give this H plus ion very lesser in number when they are dissolved in water. So those acids which are able to readily give H plus ion or which gives more number of H plus ion when it is dissolved in water, means same amount of water or per unit volume of water, then we said that acid is stronger, or the strength of that acid is more, or that acid is rather more concentrated. So this strength, stronger, concentrated are nearly related to each other, and this gives the number of replaceable H plus ions for acid and OH minus ions for base. Now this H plus ion and OH minus ion are available for the chemical reaction. So whatever chemical properties that we have learned, it is because of the H plus ion and OH minus ion. So what are the various chemical reactions? Those things we have also finished. So today we will focus over the strength of acid and base. So to indicate the strength means number of replaceable H plus ion for acid and OH minus ion for base, we are using a scale called pH scale to quantify that how much H plus ion is given by the acid. It is possible that for the acids, some of the acid are giving more H plus ion, other are lesser H plus ion. More H plus ion, they will have one pH value, and lesser H plus ion will have some other pH value. So this pH scale is a range of number which basically tells the concentration or number of H plus ions or OH minus ion. So you can give either in the term of H plus ion or OH minus ion. So we will discuss about this pH scale. So this pH scale tells us how stronger is acid or base. Means acid means more number of H plus, base means more number of OH minus, then more stronger. This is stronger or strength and concentration mean nearly the same thing. That gives us the number of H plus ion that an acid can liberate when it is dissolved in water. Again, if I am talking for a stronger base, means more number of OH minus will be given by that base. Example, if I am considering NaOH, then NaOH can easily liberate or release their OH minus. But if you consider the ammonium hydroxide cannot release easily their OH minus. So ammonium hydroxide is big base, but sodium hydroxide is a strong base. So this thing we will learn today. So how stronger is this, and how this is determined, whether the chemical is acid or base and how much stronger? For that we are using the universal indicator. The single indicator which can give the idea that whether the substance is whether acidic or basic. At the same time, if it is acidic, then whether it is a stronger acid or weaker acid, those idea is also obtained. So this universal indicator is calibrated or represented over a scale called pH scale. So this way we are going to start how stronger are acid and base. So this is given by the stronger, what is given by a strength. So it is given by a strength of acid and base. A means acid and B means base. Here I am denoting like that. So it is a strength that we are going to look. This strength is given by number of replaceable H plus or OH minus ions by the acid and base. So write strength is number of H plus ion for acid or acids and OH minus ions for bases. So how much number of H plus ion is available for acid and OH minus is available for base when so light released or liberated or made available, released when it is dissolved in water. Means even acid or base, whatever the structure we are taking, when it is dissolved in water. So more the number, stronger the acid, strength is more, that we can say. Let me copy this to other page. I will explain this later. So their strength is indicated by number of H plus or OH minus. H plus for acid and OH minus for the base. So how it is varying? This thing we have to look. So students, this strength simply mean number of H plus ion or OH minus ion. So more the number, the strength is more. The number means H plus for acid and OH minus for base. More the number, more the strength. Or also called as stronger the acid or stronger the base, means more number of H plus, this will indicate a stronger the acid. More H plus is liberated, means if lesser H plus is liberated, we are always talking while dissolving water, so weaker the acid. The same thing is for base also, where we have to consider OH minus ion. So more OH minus ion is liberated by the substance in water, so a stronger the base. If lesser OH minus means weaker the base. So a stronger the base, or simply called as a strong acid or a strong base. It is simply like that. Now, how much strong is this and how much weaker is this? For that, we are using a scale called pH scale. So more H plus. So therefore, these acids can even be classified into the two. One is called a strong acid, or even the strongest acid. Two means it is varying to weak acid or weaker acid. Similarly, the base can be classified from the strong base to the weaker base, or simply weak base. A student, now to indicate this variation, we need an indicator which can indicate all these characteristics by varying their color. Another, we need such an arrangement or a scale over which these characteristics can be presented. For that, we are using a pH scale which indicates the variation of these characteristics. Characteristic means for acid, variation in number of H plus ion, and for base, the variation in number of OH minus ions. Okay. So right, to represent these and their comparison, we use pH scale. So universal indicator is used. What is universal indicator? Last day we have discussed, which can indicate both acid and base, and their color variation or characteristic variation is continuous or continuously varying from one to another, and depending on the strength there is slight variation, means there is continuous variation depending on the strength and acidic or basic characteristic. So universal indicator is used along with a scale. That scale gives the color variation called pH scale. So this pH scale is going to vary from 0 to 14, and in that one of the reason is for acid, another is for the base. Now again, in that acid can be further represented as a strong or weaker by varying their pH values. So those things we are going to learn today. Students, these pH values or pH scale is used along with this universal indicator. So this pH number varies from 0 to 14. So what is this 0 to 14? This thing we are going to learn. So this way I had explained what do we mean by a strength. I have just written everything, how the concept of a strength develops. So a strength or concentration simply mean the number of H plus ion or OH minus ion. So let me first define what is concentration or concentration of a acid, concentration of base. Background and everything is written here, but I will rewrite in the form of just definition only. Though in general form I have explained everything. So what do we mean by a strength? A strength gives the concept of concentration. So let us go. So write a strength simply mean concentration. If the term strength is given, you can consider this synonymous with concentration. Concentration is what? Concentration simply means it is a number. So it is number of H plus ions for acid, or this may be considered as number for OH minus ion. Now for comparing the number, how much total number is there? The volume of acid or base that we are taking should be constant. Otherwise it is possible that if you are taking just 100 ml of acid, say even a stronger acid, you may get some number like say 10 to the power 11 H plus ion. But if you are taking 1 liter of even weaker acid, the volume is even 10 times. So even the ionization is a bit lesser. Still we may get more number of H plus ion in higher volume. So to compare the strength, the volume of the substance always need to be fixed or constant. So number of H plus ion in given volume at the term volume, or also in given volume, or in a fixed volume. The term given itself means it is the fixed. Means if you are taking say 1 liter of, this is 1 liter of our H2SO4, and in other weaker you are going to take 1 liter of say weak acid, let me take the third one also. So you may take 1 liter of even HCl, you may take. Here you are taking the same 1 liter, 1 L means 1 liter of the weak acid CH3 COOH, acetic acid or vinegar we are taking. Then you will observe that while this is H2SO4 is kept, then you will observe that it can give certain number of hydrogen ion. This ionization is more prominent in aqueous solution. Means you are going to take half liter of say water and going to add 100 ml of H2SO4, or in half liter of water you are going to add half liter of H2SO4, and half liter of water you are going to add half liter of HCl, half liter of water you are going to add half liter of vinegar. Not vinegar, it is acetic acid, because vinegar itself contains only 5% of this acetic acid. Then you will observe that this can give us more number of H plus ion. This will give relatively lesser number of H plus ions, and this will give very less number of H plus ions. Means the ionization of this H2SO4 is very faster. So such ionization which can occur very instantly, and almost all the acids molecule get ionized, they are called a strong acid. So right, you can write this as complete ionization. What is the ionization? Means it will get converted into H plus and SO4 minus. This H plus again get attached with water to form S3O plus. In that form it will present in their aqueous solution. So this ionization is complete. But if I consider the second one, here it is also almost complete, but not as much as the H2SO4 can do. So such a substance or such an acid which can ionize to lesser extent or to least extent are called as the weak acid. So right, this is nearly complete ionization, but not the complete one. It is partial or incomplete or lesser ionization. Ionization means producing ions. The molecule get disintegrated or broken into ion. Here I had written, so this H2SO4, this will ionize to H plus and SO4 minus. It doesn't mean these two are getting totally separated, and on one side of this solution there will be H plus and other side there will be SO4 minus. No, student, this H plus and SO4 minus will be closer to each other, though they are still appear to be in paired form, but not as much bonded as the H2SO4 or conc H2SO4 is there. So this ion again going to convert back, therefore it is written as in the form of equilibrium. This case again the same thing. it can produce H plus and Cl minus, and if this is there, it can combine back. But if I consider this one, the last one, CS3 COOH, this can give you H plus, this H is being removed, okay, the last one, and CH3 COO minus, this is the ionization. A student, this number of H plus produced is very less. So right here, very lesser number of H plus ion is produced. It means we can say that those acids which are able to completely ionize to give the ions means more number of H plus ion, is called a strong acid. So these two are falling in the category of a strong acid, and this is going to fall in the category of weak acid. Now, though even the strong acid also have slight variation in their number of ionization. So how is that? So complete ionization means more strength. So we can say it have more strength. The first one have more strength, the second one have lesser strength, and this have least strength. So it is more strength or more concentration, it have lesser, and it have least strength. Now, to specify this strength, we are using a scale which can tell us how much is the strength, how much hydrogen ion is produced. So about those scale we have to learn. A student, you can write few example. So a strong acid are those acid which are able to totally ionize in the form of, or able to completely ionize. So you may write this as a strong acid means acid, the a strong acid, another characteristic called pH we will also write, and weak acid. So acids which can completely ionize, to give what? H plus ion, or to readily give H plus ion. Ultimately, more stronger, it will ionize completely, so more number of hydrogen ion will be produced. So more H plus ions. Here in weak acid, partial or lesser ionization means all the molecule will not ionize. Say this in third case, if I am considering this acetic acid, if there is, you may write some number also, if there is say 10 to the power say 20 acetic acid, then out of this only around 10 to the power 9 is going to ionize. Means this much is acetic acid molecule, but this much is hydrogen you will get. But in this case, if you have the 10 to the power 20, then all of them will get ionized. You will get 10 to the power 20 ions. Means H plus you will get. It is also nearly that. Here you will get out of 10 to the power 20 molecule of HCl. If you are taking, you will get around 10 to the power 18 or 19 H plus ions. So such compound or such acid which can ionize totally means all the molecule get converted into ions. They are called a strong acid. And those acid in which only certain amount or limited number of their molecule get ionized, not the complete one, it is called as the weaker acid. Okay, students? So this vinegar or acetic acid is weaker acid, but H2SO4, HNO3, HCl, these are a stronger acid. Now, are you getting this point? This is very important. So in term of number, you must no need to mug up. I have just explained by taking 10 to the power 20 number. It even contain more than that. That is expressed in the term of moles, and you will learn more in your higher standard. So if we consider in the term of ionization, the weaker acids ionize this partly. So partial ionization to give lesser number of this H plus ion, lesser H plus ions. It is this one. Now, example you have to write. Along with the example, how much is this strength? For that, we are using the pH scale. So let me write the pH range. So pH range, the pH values varies from, it is a stronger one, than a stronger acid have lesser pH value. That we will discuss just within few minutes. The strongest have the least one, means it can vary from this 0 less equal pH value. The neutral have been given the pH value 7. So if it is reaching to 7, then it become neutral. So this acid have the pH value 0 to nearly 7. But out of this 7, if the pH is laying lesser than 3 or lesser equal 3 rather, then it is in the category of a strong acid. And above 3 but lesser than 7, that is in the category of weak acid. So in this case, the pH values varies from 3 to around 7. If it is exactly 7, then it is neutral. So this is the pH range that we have to keep in. This is intermediate one. I mean the 3 is intermediate one. You may remove this one also. Let me write few example. Various acids that we have already written, like H2SO4, HNO3, HCl. These are a strong acid. These are also called as mineral acid. And organic acid means acid of carbon, they are weak acid. Even this acetic acid, CH3 COOH, even HCOOH, even the tartaric acid, all these things, lactic acid which is present in milk, they are the weaker acid. So these are mostly organic acid. organic acids are weaker acid. These are mostly mineral acid, mineral or non-organic. Means acid which do not contain carbon are called mineral acid. Acid containing carbon and hydrogen are called organic acid. About organic acid we will learn in chapter 4. So the pH range you have to keep in mind. Their example you also have to keep in mind. So this was about the strong and weak acid. Now how to express this? Similarly there is weak base also. So right, let me explain that. Write down the strong and weak base. Again, the strength is more, it will be stronger, whether it is acid or base. So let me write, I'm directly going to write the strong base and weak base. For this base, the pH values varies from 7 up to 14. This is the pH scale that we will draw. Now, strength is measured in terms of OH minus ions. If more OH minus ion is given, then it is called as a strong base. If lesser OH minus is there, then it is called as weak base. So right, this can be further classified into the strong base and a strong base, again those bases which are completely ionized to give what? OH minus ion. So completely ionizes to give OH minus ions. We have lot. This OH minus is common to all the base. So if they are able to completely ionize, then it is called a strong base. It is partial ionization. Means whatever the molecule you are going to add in water, all of them will not ionize. Some of them will ionize, some of them will remain unionized. That I had explained. So this a strong base have the other tendency also. Let me shift it forward. Still there is a space. So other characteristic regarding pH can be written for this strong and weak base. So write down those characteristic. Then we will write the example. Here the pH value we will say a stronger base means more OH minus, means lesser H plus, so more the value of pH. So pH range is above 10 or 11. So write that one also. So if you are taking the pH range, so this pH, maximum pH can be 14. So it starts from 10 or 11 rather. And in this case, it varying from 7 to 11. It is 11, not the H. Rather than 11, it is better to keep it as 12. बहुत book में 11 मिलेंगे, बहुत book में 12 मिलेंगे. So don't worry for that. Roughly you may consider the 11 is the safe one. So it is this one. A student, what are the example? If we write the example, the strong base, all the alkalis are not bases, but few of the alkalis. So alkalis are a strong base. So like NaOH, KOH, whatever the other thing you can think, you may, like even this calcium hydroxide, nearly but not very much. If we consider the bigger one, the example is like this. Best one is ammonium hydroxide. It is called the bigger base. So the alkalis are falling in this category. Even some of the salts are also bigger, like carbonate, calcium carbonate, all those things. So we will discuss that at salt. So strong salt, weak salt, there we will discuss. Whatever the characteristic for a strength, the same thing is also applicable here. A strong means the more concentration of OH minus. Weaker means it have the lesser concentration of OH minus. We have to understand how this OH minus concentration give the idea about the H plus and what the pH scale is now. Now, more concentration of OH minus means the chances of getting H plus is very, very less. Means lesser chance of H plus. It means if we make a scale based on H plus only, then its value will be very less. And if we are making in term of OH minus only, then the scale value is more. A student, we are using the scale called pH scale, which is reciprocal to the number of H plus ion. So what is that pH scale? How it is expressed? Those things we are going to learn. So students, let us start with our new topic called pH scale. So to quantify, or you may write here, to quantify ionization may be given in the term of H plus or OH minus. The amount of ion means either H plus if we are considering the acid, or OH minus is expressed as concentration concentration or a strength simply, or write down the strength and plotted on pH scale. So what is this pH scale? I'm going to explain that. So let us start with this topic. What is our pH scale? So we have discussed strength means ionization. Based on that, the classification is stronger and weaker, acid and base. Example are very important that you have to keep in mind. Now we are going for pH scale. What is pH scale? So write down pH scale. So pH scale is nothing but it is simply a scale over which this strength or the amount of hydrogen ion liberated or OH minus ion liberation capacity is presented. It is so simple thing. Okay, so write about this pH scale. It is a big topic. You will learn in more detail in higher standard class 11th and 12th. There are certain limitations also of this pH scale. So how these are calculated? Calculated with the help of reaction equilibrium. So those things you need not learn here. So I will just write what is the definition and how it is classification and what is the range. Only those things we have to learn. So we will remain confined to that much one. Students, this pH scale tells us quantitatively means it is not telling us just as a strong acid and weak acid. Even if it is a stronger, then how much is a stronger, which one is a stronger to which one, all these things can be observed. So right, to quantify or quantitatively know the amount of ions. It may be your H plus or OH minus. So it gives the quantitative, means in a number. Quantitative means in number form. This scale basically this amount of ions in a given volume of this solution. You may add that term also, in a given volume of solution. And in class 9th even we have learned, in a given volume of solution, what is the amount of solute or what is the number of solute, that gives us the concentration. So this amount is expressing what? Concentration. Higher the concentration, more the strength. So what is this pH scale? So this concentration is expressed in the term of either H plus or OH minus. You are free to express in both H plus or OH minus. Even this H plus and OH minus are interconvertible through a formula. So this pH scale is defined in the term of H plus ion. The definition is in the term of H plus ion. You can also express, or you can also tell this in the term of OH minus ion, but this H plus ion is preferred. So how much is the concentration of H plus ion? Means how much H plus ion is present in given volume of the acid or diluted acid that you are taking, that will give us the pH value of that acid. Okay. So right. So it is a scale for measuring the hydrogen ion concentration. So it is a scale for measuring hydrogen ion means H plus concentration. If I am using the term concentration, it automatically fixes the volume, means in a given volume we have to think. So student, it is the scale for measuring the hydrogen ion concentration. The definition is like this. It doesn't simply mean if the hydrogen ion concentration is more than pH is more. No, the definition is related to logarithmic scale. So if the hydrogen ion concentration is more, the pH is lesser one. So right, this can be simply tell or written like this. So it is number of moles of hydrogen ion in unit volume of the solution. So right, this is basically means what this scale is this and what is this concentration. It gives simply the number of moles you have used the term, because this way the definition is asked in NTSE. तो आप ये मोल्स के टर्म में बस ध्यान रखिए, नंबर ऑफ मोल्स ऑफ H plus ions per unit volume or in a unit volume, in unit volume, or it may be 1 liter of solution, or rather it may be the solvent. This is basically called the molarity. In class 9th I had listed there are various ways of expressing the concentration, like it may be molarity, it could be molality, it could be normality, it could be the mole fraction, it could be the mass percentage. There are various ways, but generally what we are considering is this one, means we are counting how much moles of hydrogen ion is present in 1 liter of the solution. If more moles of hydrogen ion is produced, then its pH value is taken as less. Why? Because the definition is taken on the logarithmic scale. So right, this pH, if you consider this P and H, here this P whatever we are using, this P stands for, P means it is our protons. It simply, even this comes from the term proton. This proton is what? That we have already learned in class 9. So proton is nearly similar to hydrogen plus. When electron is lost from the hydrogen and hydrogen do not contain neutron, so it becomes identical to this proton. It is this. So how much H plus is present? The term uses P. H plus means proton. So how much, that is expressed in the term of their power. So P to the power H. So this is the meaning of this. So this proton is basically a German word. If you want, you can write German word from there. the meaning is again the proton itself, which simply means H plus. तो भूलना नहीं है, क्योंकि student may forget कि what is that. So to express this, it is P to the power H is used. Now how is the definition? So it is negative logarithm or log of hydrogen ion concentration. Write this. Hydrogen ion concentration. Students, this is the definition of this scale. So pH was defined as negative log of, means negative you will take once, then log of hydrogen ion. Hydrogen ion in which term? Hydrogen ion concentration. Means if you are taking a solution, say it is 1 liter exactly, if I am taking, this is our 1 liter only. In this we are measuring how much hydrogen ion is there. So number of hydrogen ion per liter, this is called as concentration, and this is denoted as putting this H plus in a square bracket. It is the denotation for this one. So concentration simply means you are taking the solution. It may be your H2SO4, any of the acid that you are taking, and this solution is of the 1 liter one. So in this, how much is the hydrogen ions in this 1 liter of the solution, that will give the concentration. So it will simply a number. Now this concentration have to be attached with mathematically with the log, and there we have to put even a negative sign. So therefore write down this pH is given by, see, negative means you will put this minus sign. Okay students, log is the scale. Why log scale is used? Because see, if you consider the number of moles of, it is basically the moles, number of moles of H plus, moles you are knowing that this moles, their number is 10 to the power 23. 6.22 into 10 to the power 23 is called 1 mole. So this much bigger number, so handling this much bigger number is quite difficult. Therefore log scale is preferred. More detail you will learn in higher standard, students. But you must just understand why log is taken, to handle the bigger number, because the number of ions or these smaller particles are quite large, 10 to the power 23, 28, 30, up to that much. To handle that, log scale is used, where the power just get converted into multiplication. So it is negative log of H plus. So write down the concentration is written as H plus. So it is denoting this. So write this or bolden this. It is simply this. So what is the concentration? Their log. Now a student, from here what we are observing, if H plus ion is more, then concentration H plus bracket will be more. Say more, or before considering this, let us apply. This is the definition. But what is the property of log? Minus simply means this is similar to this, minus can be absorbed. Like in mathematics, we know that if we have a to the power minus m, this can be written as 1 by a to the power m. Okay? In the similar fashion, if there is minus log of a, this is nothing but it is like 1 by log of a. Okay, this is the mathematics. So if you consider this negative, this can be converted into positive by writing this log h in denominator. Okay, student. Now, both mean the same thing. So whether you remember this first one or this one, both are same. So these two are same. From the first, a student may get confused that if H plus ion is more, then pH should be more. No, a student, it is the negative logarithm. Negative logarithm means H plus ion concentration will now come in denominator. This is the mathematics that I have written. So now, if we consider H plus is more in given volume, so concentration will be more. It means even if we are taking the log with this one, it will be more. But if I am taking the reciprocal of this one, a student, just let us understand one more mathematics. This 3 is greater than 2, or let me write this 4 is greater than 2 basically, for simplicity. 4 is greater than 2. You are knowing? No doubt? But if I am taking 1 by 4, then which one is greater, which one is smaller? A student, just tell me quickly. 1 by 4 will be greater than 1 by 2. Is it okay?
Sure, sir.
The sign get reversed. So ये चीजें बच्चे भूल जाते हैं, इसीलिए इनको डाउट रहता है. तो मैथ्स तो हर जगह है. So applying this concept will be lesser. It means if more hydrogen ion is produced, then this is called as what? Log value. So pH value will be lesser. अभी आपको बात समझ में आई कि हाइड्रोजन आयन कंसंट्रेशन ज्यादा होने से पीएच वैल्यू ज्यादा नहीं कम होता है. ओके स्टूडेंट्स, सो thus higher the, so let me write, thus, or let me write here itself, because I'm going to stop the class immediately, because right now I have watched the clock. I may get late for my office. So write higher the concentration of H plus ion, lesser is its pH. Let us stop it here. Then from where it will start and what is the range, this we will discuss at evening. So evening this pH will be finished. Okay, so let us keep the class for evening also. So student, know that our next class at today evening around 8 o'clock it will start. I will try to finish early, because once this pH topic will be finished, class will be ended at today evening. So pH में अपने को दो चीजें बाकी रह गई है. pH स्केल क्या है, इंपॉर्टेंट एसिड्स बेस के क्या pH रहते हैं जिसे हम यूज करते हैं, एंड कौन कौन से कंपाउंड है उसका, उसमें कौन कौन से टाइप के एसिड्स हैं जिसे हम खाते हैं वो याद रखने हैं, एंड सम इंपॉर्टेंट फेनोमेना. हार्डली नियरली 1 more hour इज रिक्वायर्ड. सो इवनिंग को नियरली 1 hour का क्लास रहेगा. So please do not forget to join. Let us stop the class. Student, please vacate the class very quickly because I am getting late. Okay. So thank you,
Thank you,
student.
sir. Thank you, sir.
Thank
Thank you,
you.
sir.
Thank you, sir.